Hello, this is Jean from Megra's Academy. In this video, we are going to compare fractions. For fraction comparison, the first scenario that you may encounter is that the two fractions can have the same numerators. In this case, the fraction with the smallest denominator is the largest, and we can write it as a over b is greater than a over d if b is smaller than d. And let me give you an example. We're going to do a very simple example. Is 1 over 2 is bigger than 1 over 3. And it's kind of a little tricky to understand, but it becomes easy if you can illustrate with a pie. Let's do a pizza or a pie. But basically, you want to draw. So these are same size, equal sized pies. And for the first one, we're cutting this in half. And for the second one, the one on the right, we're cutting this into 3 equal slices. And for both of the pies, we're just taking one part. We're taking one part out. And we're comparing, right? We're comparing these parts. And obviously, the part on the left is bigger than the part on the right because you have divided into smaller slices. Now, the second scenario is actually the easiest one, and it's very intuitive to understand. So the second scenario says, for fractions with the same denominator, the fraction with the greatest numerator is the largest. And we can write it as a over b is bigger than c over b if a is bigger than c. Example, 2 over 3 is bigger than 1 over 3, right? For this one, we don't even have to draw a pie or a pizza, but, I'm just gonna draw it so that, we can compare this to the first scenario. So, I have done my best. I think they are almost equal size, right? Now, we can do this for the first one. Yeah, we are dividing the pizza or the pie into 3 equal slices for both of the pies. And then what we're doing is that we're taking 2 parts. We're taking 2 parts out of the first one, and we're only taking 1 part out of the second one. And obviously, the one on the left is going to be bigger than the one on the right because all of these are divided into first, the same number of slices, and second, all of the slices are equal. So the one on the left is going to be bigger than the one on the right. And so that's why I'm saying this scenario is it's the easiest to understand. And that's why when we have the most difficult scenario, which is when you have 2 fractions with different numerators and different denominators, you want to make them into the second scenario, which is that they have the same denominator. Okay, so we're going to write it as to compare A over B versus C over D, where A is not equal to C and B is not equal to D. Then we need to somehow make B equal to D, right? We somehow need to find a common ground for the comparison. And for that, you actually just do A times D over B times D versus C times B over D times B. And why do we do this? And why can we do this? Is because A over B is equivalent to A times D over B times D, because you are multiplying the numerator and the denominator with the same number D, and at the same time C over D is also equivalent to C times B over D times B. Same thing, right? You are multiplying the numerator and the denominator with the same number, and they are equivalent fractions. And if you observe here, B times D is equal to D times B, right? And by doing this, you have made the fraction, the two fractions having the same denominator. So at this time, you can compare them. And you are comparing not the original fractions, but their equivalent fractions. So let me give you an example. Let me give you a simple example. So let's do 5 over 7 versus 2 over 3. So instead of comparing these two directly, we are going to compare 5 times 3 over 7 times 3 versus 2 times 7 over 3 times 7. And the left becomes 15 over 21. The right becomes 14 over 21. And now they have become the second scenario where you have the same denominator, and because 15 is bigger than 14, so 15 over 21 is bigger than 14 over 21.